So our problem of the day was kind of a peek into what we were going to do today. We were talking about, well, in our warm-up we did 3 equations with technically 3 unknowns, right? When we are working with a linear equation that has x, y, and z, okay, we're talking about free space, and it's representing a plane. So yesterday we were talking about 2 lines, where do they intersect? Today we're talking about 3 planes, where do they intersect? So go and write this down. Now, maybe you remember the strategy you used last year to solve these. I don't know. But the strategy that I think is the most efficient is to use elimination either once or twice to get your equation, to get this system down to 2 equations with 2 variables. So what we want to do is we want to eliminate one variable twice so that we have 2 equations, 2 unknowns, because we're really good at solving numbers, right? Yes. Okay. What would you like to eliminate, x, y, or z? Isn't z already eliminated from one equation? Right? Alright, so let's eliminate z. Half the work is done for us. Here's one of my equations that I can use. Okay? Now, let's eliminate z from the first and the third. If I want to eliminate z from the first and the third, what do I need to multiply the first one by? 5. We'll do positive 5. So 5x minus 10y plus 15z equals 45. And the third one we would have to multiply by negative 3 because we want them to be opposite. So we have 6x, negative 6x plus 15y minus 15z equals negative 51. So now when we add these two together, we get negative x plus 5y Now I'm going to write this one down here. We have negative x plus 3y equals negative 4. Here, now we have 2 equations with 2 unknowns. Okay, so now we're going to focus on these 2 equations. How would you like to solve for x and y right here? Okay, you want to use elimination where we just multiply 1 by negative 1? Okay. So let's take the first one, and I'll multiply it by negative 1. You know what? I better rewrite this. Okay. So I'll multiply this by negative 1. So we have x minus 5y equals 6. I'll rewrite our other equation. And when we add these together, the x's go away, and we have 2y equals 2. Negative 2y equals 2. So y is negative 1. Okay? Once we get one variable, we can slowly work our way backwards. Okay, so now that I have y, I'm going to hop back up to this system of 2 equations, and I'm going to use this to help me find x. Which one would you like to choose? Yeah, isn't that this one right here?
Oh, okay. I thought you meant like plug it in back in that one.
Oh, no. When I say plug it back into the system, we can choose one from here and plug it back in.
Okay. Yeah.
Well, not always. If your original system has all three variables and all three equations, that's not going to be very effective. Okay, so we're going to hop back up to here. In this case, we could go to the middle equation, which is the same one as is here on the right. All right, so if we plug in negative 1, we have negative x plus 3 times negative 1 equals negative 4. Negative x equals negative 1. So x is 1. Now we can jump back to our original system, and we can pick one of these to find z. Which one would you like to choose? The top one.
Negative 1 is negative 3. Not positive.
And then I add it over to here to get negative 1.
Negative 3. Oh.
Okay. So now we have x minus 2y plus 3z equals 9. Do you agree? 1 plus 2 is 3. I move it over so we get 3z equals 6. So your answer, which yes, I want you to write it as an ordered triple. One, negative 1, 2. Questions? The answers are normal, huh? Okay, write this one down. Okay, so we need to choose a variable to eliminate twice. Would you like to choose x, y, or z? Z or y? I'm hearing a lot of z's. Okay, either way it's set up very nicely, isn't it? Okay, let's take a vote. How many want y's? Z's. Z's it is. Okay. So, you want to take the first and the third? Okay, so I'm going to take my first equation and my third equation, and when we add them together, we get 4x plus 2y. Our z's conveniently cancel, equals 8. I'm going to box it so I know I want to come back to that. Okay? Sammy, you want me to do the bottom two?
Or better, like the Y's and the Z's would cancel.
If we add the bottom two together, we get 5x equals 5. So now, here's my system of two equations, right? This is easy from here, correct? We don't have to do so. Well, I guess we kind of do substitution, but we already know that x is 1. So where should we plug x into? This one, this 4x plus 2y equals 8. All right, that way we can get a y. So we have 4 times x plus 2y equals 8. 2y equals 4. So y is 2. Now, we can pick one of our original equations to plug these back into. So which one looks nice? The top one. Okay, anytime you're solving for a variable, it's nice but has a coefficient of 1, right? So we have 1x plus 1y plus 1z equals 6. So Z is 1, 2, 3? Z is 3, so her final answer is 1, 2, 3. Okay. Can we check our answer? We can always check our answer. Isn't it nice knowing that you did it correctly? It is nice knowing. Okay, so 1 plus 2 plus 3 equals 6. Let's check this one. What is 2 times 1? Minus 2. Plus 3. Hey, all right. 3 times 1. Plus 2. Minus 3. All right. This works in all 3 equations. That should happen. Okay? If you're going to check your answer, you need to check it in every single equation because it has to satisfy every single equation. Okay? Now, please be careful when you are doing these problems. It is very easy to make an arithmetic mistake. Okay? Forgetting to distribute, let's say you multiply one of your equations by a number. Very easy to forget to distribute all the way through. Maybe you miss a negative. Maybe you add incorrectly. Make sure you take your time when you do these, okay? Because it's very easy to just make one little simple error. Now, if that happens, say you get to the end, your answer does not check out. Go back and look for your mistake. Do not erase everything right away. Okay, you're wasting your time if you do that. You might be able to find that, oh, I didn't add 2 plus 3 correctly. Okay, even though it seems really easy, sometimes we accidentally multiply instead of add or something silly. Okay, so please be careful and take your time. Okay, you should always know if you have the correct answer. So everyone should get 100%, right? Everyone's so positive. All right, we're gonna do word problems. Turn in your books to page 529. We're gonna look at number 60. Share with your neighbor if you need to. All right. Ethan, read it to us.
Forrest is creating 10 centerpieces for a wedding. The florist can use roses that cost $2.50 each, lilies that cost $4 each, irises
Uh-huh.
that cost $2 each to make a bouquet. The customer has a budget of $300 and wants each bouquet to contain 12 flowers. With twice as many roses used as other types of flowers combined. How many each type?
Okay. So, what are our variables?
Flowers, lilies, irises,
Now, are these total roses, lilies, and irises, or are they in the bouquet? You want them to be total?
well, what that could be easier to do, okay.
Bouquet or total? All right, let's take our first bit of information. What's the first thing it gives us?
10 cents.
10 centerpieces, okay.
That's the number of bouquets that we have. Like that.
Then you have to use total flowers.
What did you say?
10 flowers, yeah, 12 flowers in a centerpiece.
then we got 1,000 total flowers.
Okay, well now these represent how many flowers are in a bouquet, right? So x plus y plus z would need to equal what? 12. If your x, y, z, if your variables represented total number of roses, lilies, etc., then it would be x plus y plus equals 120. Okay? Then it gives us a budget, $300. Now that's for their total budget, correct? So 30 per bouquet. Okay. So we need to group this with what other information?
How much each is
How much each of them cost? How much do the roses cost? How much do the lilies cost? And irises? It also says that the roses are twice the number of the other two. How do we write that?
Where's the same twice as many as the other two?
Combined. Okay. Okay, let's think about this. There are twice as many roses as there are the other flowers. So if I want the roses to equal the other flowers, I'm going to have to double the other flowers so that we're balanced. Right? Looks backwards, but it makes sense this way, correct?
Yeah.
Okay. So let's go ahead and rewrite these into a nice system. Right? We have x plus y plus z plus 12. We have 2.5x plus 4y plus 2z equals 30. And then I'm going to write this as x minus 2y minus 2z equals 0. Okay. All right. So let's pick a variable to eliminate. So you want to eliminate z. Okay. So if we take the first or the second and the third, let's just go and do this right here. Save some room. If I add the second and third together, what do we get? 3.5x plus 2y, our z's cancel, equals 30. All right, now we need to combine the first with something to eliminate z. The third? Okay, in order to do that, we're going to have to multiply the first one by 2. So we have 2x plus 2y plus 2z equals 24. And then we're picking the bottom one. X minus 2y minus 2z equals 0. So we get 3x. Ah, this is nice. What's x? 8. Alright, which means we can come back here to this other green equation and figure out what y is, correct? What's 3.5 times 8?
Oh, sure.
28. So 2y equals 2, which means y equals 1. Now, what equation do you want to use to find z? The first one, x plus y plus z equals 12. So x plus y plus z equals 12. So z is? You will not give me an ordered triple for an answer. Okay? They are asking us to tell them how many flowers of each do they need in one bouquet. So, in one bouquet, there are 8 roses. There is 1 Lily, and 3 irises. Once again, be very careful with your work. Pay close attention so you don't make silly mistakes with your arithmetic. There will be a quiz on Tuesday. There are twice as many girls as the others. Those are X. There's twice as many for this to be equal to the other flowers, I have to double the other flowers. Since there's twice as many.